Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
The 27th edition of the Novaspace Satellites to be Built and Launched report forecasts that an average of over 3,700 satellites will be launched annually between 2024 and 2033, equivalent to about 10 satellites per day. NOAA's Office of Space Commerce, or OSC, is developing the Traffic Coordination System for Space, called TraCSS, to provide basic space situational awareness data and services to civil and private space operators, and to support spaceflight safety, space sustainability, and international coordination. My guest on this edition of the Ex Terra Podcast is Christine Joseph, Policy Advisor at the Office for Space Commerce, currently supporting the TraCSS program. Christine, thank you for joining me.
Thank you very much, Tom, for having me.
Happy to do that. So let's start out basically with what TraCSS is and what are the primary objectives.
Sure. So TraCSS, which stands for the Traffic Coordination System for Space, is really geared towards supporting spaceflight safety, space sustainability, and international coordination for satellites and space operators worldwide. In one way to think about it is TraCSS, all these satellites that are orbiting around the Earth a lot of them are able to do their own controls. They're autonomous, but many of them are actually controlled on the ground by operators sitting on the ground here on Earth. So what TraCSS does is help provide the information around where these satellites currently are, where they're going, and help provide safety notifications to those operators on the ground so that we can help avoid collisions. Space is really large, collisions can happen and in fact have happened in the past. And the debris from those collisions really causes a lot more congestion in the space environment and makes it more difficult for space operators to do the missions that they want to do because they have to move around all this debris or other space objects. So TraCSS is really aimed towards providing this safety service around where space objects are and providing those notifications to space operators, along with data for folks to be able to make their own decisions as well. And we're doing it by combining the best of government capabilities, but also a lot of commercial and industry capabilities that are out there today.
What motivated the development of the system?
So it's there's a bit of history to it because for years, the U.S. Department of Defense has actually been providing this information worldwide since the early 2000s, I believe. The Defense Department has had these sensors that were used around the Cold War era for missile warning and defense and whatnot. Mm-hmm. Turns out these sensors can also be used to see the satellites that are up there in space, too. And now in the early 2000s, there happened to be a collision between Iridium, which is a commercial operator, and a defunct Cosmos, a Russian satellite. Right. And that collision resulted in a lot of debris in the space environment. And after that, the U.S. Department of Defense started giving out at an unclassified level some information regarding what it knew about the space environments. And it's really grown over the years where they've kind of been a key enabler to spaceflight safety operations. Now, Department of Defense also really wants to focus on their own defense and national security missions, and there's been a big growth in space activity as well. So there was kind of a back and forth in the U.S. executive branch, Congress, and whatnot. In 2018, the White House National Space Council released a policy directive or a document stating policy and direction to the government agencies, directing that Department of Commerce should actually work with the Department of Defense to start providing this basic information about where satellites are, also known as space situational awareness, and help provide the services to provide those safety notifications, also known as space traffic coordination. So, but that was back in 2018. And then in 2020, there was a study about where should it actually belong with Congress or with the Department of Commerce, which it did, which the study verified. And then in 2023, NOAA got increased funding. NOAA is the National Oceanic and Atmospheric Administration, and that's where our Office of Space Commerce, sits inside of. So we got increased funding to be able to start building out tracks at scale, at an operational scale that it needed to be at. There's been a lot of development and growth since 2023 to get us where we are today, and when we're still developing, but it's been years in the making.
And we'll get to some of that in just a little bit, but you had mentioned that you're integrating commercial SSA data and services. How does TraCSS do that integration, and what benefit does that bring to satellite operators?
Right. So I mentioned how, to give background about the commercial capabilities that we're taking advantage of. Mm-hmm. Department of Defense had been providing those services, but a lot of these satellite operators, they had more needs beyond what the information that the Department of Defense had been providing. So there's kind of been this burgeoning industry of commercial space situational awareness providers, whether it's companies that run their own sensors on the ground to track where space objects are, or companies that are more on the software side. So taking that data or taking the Department of Defense data, doing extra analytics, looking into the quality of data, helping satellite operators actually pick the next best maneuver that they should take. So there's been a whole industry that's grown around that. So what TraCSS is doing, and what it's being developed to do, is using a combination of government infrastructure on the digital side, the software infrastructure for TraCSS, to hold a repository of information about these space objects. Having all the cybersecurity controls and user login and whatnot is government infrastructure. But the apps, similar to the apps you have in your smartphone, will actually be procured from this industry who has a lot of developed capabilities out there.
You've mentioned a couple of times objects. Does TraCSS track not only satellites, but other like defunct satellites and space junk?
So TraCSS won't actively track things. So the Department of Commerce, we don't plan to necessarily own or build our own sensors. We'll be getting data on these objects from what Department of Defense currently has, the unclassified information. We're also going to be buying data from those commercial space situational awareness objects, companies. But yes, it will, and any space object, whether that be an active satellite and any unclassified space object, whether that be an active maneuvering satellite, a satellite that's defunct, or to the degree that we can, or that existing capabilities can reliably track it, we plan to do the safety screenings against those objects. There is a whole host of dangerous debris out there, though, that are lethal but quite difficult to track.
And it's all moving very, very fast.
Yes, we are. People draw a parallel to air traffic control sometimes, which I think is like a good way to start approaching how to think how space traffic coordination works. Because you have a lot of planes up in the air, you have your air traffic controllers telling them where to move and whatnot. But I mean, for one, it sounds cliche, but space is quite large. As you mentioned, the objects are moving thousands of miles per hour, and there's a lot of uncertainty as to where they are too. You can't pick in a pinpoint exactly where a space object is. There's almost like this whole bubble of where it could be. So it complicates the safety screening process a little bit more.
Now, OSC has described the rollout on the website as a crawl, walk, run strategy. Tell me what that means.
Sure. So we are taking intentionally an agile development approach to how we're developing tracks. And for those that are more familiar with software development parlance, and this is applicable to almost any field, but it's really trying to iterate build incrementally, make sure you're incorporating user feedback throughout the design process. So trying to move away from a classical systems engineering approach where you spend years trying to define all your requirements and then you spend years building it. But it could be by the time you're 2/3 of the way building it, half your requirements are obsolete by then because technology's changed, people's needs have changed. So we're intentionally taking an agile development approach where we start with a minimum viable product to get things out to our beta users. We take in their feedback and we build on capabilities over time. I used the cell phone analogy earlier, but just like on your smartphone, you have a major software release like iOS 10 on your iPhones, but then you have incremental upgrades, and then you do at iOS 11, which is another big capability as well.
Now, recently, TraCSS 1.0 went live. You talked about kind of the bare bones basic model of it, and that's operational now. So what does that mean for commercial operators?
Right. So we're super excited that to have launched our TraCSS 1.0 release. What this means is, so this is similar to what I described as that minimum viable product, where a beta set of satellite operators, so it's about 9 different satellite operator organizations, can now, their satellites are now being screened by TraCSS. So the base part of the software is up enough to take in all the information from the Department of Defense, take the information of these different about 1,000 satellites, screen them to see if there's any potential collisions, and then produce safety notifications, also called conjunction data messages. A conjunction is basically a potential in-space collision. And then it's available to them via they access those safety notifications right now through the current DoD legacy website, the DoD website, because we're still, as I mentioned, building incrementally. One of the next increments is actually getting our website interface up for people to interact more directly with the system. But we are taking the step to make sure that that safety notification, that key product, that these operators can start evaluating it, give us feedback, let us know if there's any issues. Can they even access it? Which, happy to say they can. And we can start iterating that. So it allows us to make sure that we're still delivering things to our end users at the end of the day, but that doesn't stop us from developing the system further.
You've talked often about how it's accessed like a cell phone. It's basically Internet of Things, it sounds like to me, is how the system works. What kind of security measures are you putting in place to make sure that bad actors don't access the system and give you bad data?
That is a great question. That's kind of a key aspect of why that software backbone for TraCSS is being built on using government infrastructure. Because then we apply all the best practices when it comes to cybersecurity controls, whether it's standards from NIST, which is a government organization that has played a huge role in cybersecurity, but also puts out standards and best practices and guidelines used across the U.S. and the world, whether it's digital systems or what is actually a kilogram, for example. And then, so that access point is just kind of government infrastructure. And then we also plan one of those apps that we plan to have beyond kind of basic checks and balances is to actually do data quality monitoring. So checking when people submit information, and we expect them to submit it in good faith, like not intentionally trying to spoof the system. But doing checks around, like, does this make sense? Looking in hindsight, whether you have any data streams that are looking off or whatnot. So, there's various checks and balances throughout the system.
My guest is Christine Joseph, Policy Advisor at the Office of Space Commerce and currently supporting the TraCSS program. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Christine, what did OSC learn in the various listening sessions that were held prior to the TraCSS rollout?
We've learned a lot whether it's kind of policy questions around, people had a lot of questions about how we would use their data, to very specific technical issues around, like, when I send my information about my satellite to TraCSS, what format does it need to be in, or what format are you all planning to require? For background, I mentioned we're taking an agile development approach. Before we fielded the system, we also wanted to try and get feedback from the public, our different stakeholders, whether it be satellite operators or the commercial companies we plan to buy things from, or even the general public, because we want to make information available to them too. So we've been hosting about every 2 months or so kind of live webinars where we'll propose a topic and then really take in questions and that we can take back to our technical team. So some of the listening sessions have been on data standards, which sounds really trivial. Like, why would you host a whole several 1-hour sessions on how to format your data correctly? But it really plays a huge role in being able to share this type of information, and making sure that your software can intake it correctly. The more interoperable the data is, or people are using the same data standards and formats, the better that we can even share information to other satellite operators and also talk to other countries too.
And it would seem that all of the data has to be formatted the same way in order for the system to be able to use it properly.
That's what the plan is right now. I think right now the status quo, people have been used to kind of doing the best that they can, but we really need to move forward, not just in terms of making the safety screenings higher quality and more accurate for everyone, but also so that when we are talking to European satellites or satellites in Asia or whatnot, that we know that we're talking about the same thing, and we have the same metrics or safety thresholds to be able to compare things to.
Then how does TraCSS support the U.S. priorities, the U.S. Space Priorities Framework and the Space Policy Directive number 3?
So that 2018 directive that I mentioned, that's Space Policy Directive 3. And then the Space Priorities Framework that I believe came out in 2021. You may need to double check me on that one. Also kind of supported, mentioned in line how Department of Commerce, we're building TraCSS as a civil space situational awareness capability.
What technology, and don't worry, I'm not in the fact-checking business. well, I'll just take you at your word on that one. Let's talk a little bit about the technologies and innovations that are being integrated into TraCSS to enhance space situational awareness.
Right, so I mentioned earlier how the different commercial companies that are out there, some build sensors, some are more on the software analytics side. So it's really taking into account, so it's a combination of purchasing what data that we need to help augment the system for the safety mission that we have, which is different than how some of the more national security organizations, they have different interests when they're looking at objects in space. We just want to make sure satellites don't crash. Right. So there's different veins of the data that we need. And then there's the software analytics perspective, whether that's going into astrodynamics and how different companies code up different astrodynamics algorithms or whatnot, to perhaps in the future, right now there's a lot of companies looking at how can you take advantage of different technologies around big data science or machine learning to learn more about the space environment. So we actually hope to, with TraCSS and making a lot of this information to the extent that we can, we want to make it public to the extent that we can, because that's actually one of our objectives, is to support advancing the state of the art of SSA, or space situational awareness. There's unknowns, especially this area of space weather, plays a huge role, because space weather is when, like, the radiation from the sun fluctuates or changes,
Right.
those particles actually affect the satellites in space. They can make them slow down, they can make them drift, and it makes it harder to be able to get a sense of where exactly they are in space. So there's tons of gains to be. There have been lots of gains to made in the past few years regarding the modeling around space weather, working with the satellite operators who give us information about where their satellites are. But definitely a lot more to be done, especially considering all the satellites that are kind of impacted by that more and more in the recent years.
Something that you just said sparks another question in my mind, and that's how you're integrating AI and machine learning into the system. What role is that going to play in TraCSS?
So right now, in kind of the operational side of TraCSS, we don't have plans to integrate it right now. However, I do believe that the data that TraCSS is going to be providing can help enable that. There is a lot of data that the Department of Defense provides today, and we will become that disseminator instead of DoD. We'll be kind of a civil face for providing a lot of public unclassified information. So the hope is that by us in the near term, we make this data available, and different, whether it's companies or researchers, can leverage that to apply machine learning or big data science types of methods. And then who knows in the future, perhaps there is a tool that we need for spaceflight safety that leverages machine learning or one of those different methods, and then we can go procure that later. We're trying to be as flexible as we can with TraCSS, because the space environment is going to change. The needs to keep things safe is going to change, and the marketplace for what we want to bring in as a capability is going to change too. So we hope to, whatever helps support safety, we hope to be able to take advantage of that.
I mentioned at the top of the program that there are forecasts that as many as 10 satellites a day are going to be launched over the next decade. That's a lot of spacecraft going up. And that's based, I would think, on the pace of things that are being launched now. How do you see TraCSS handle the increasing number of satellites and almost by definition orbital debris that's going to be gathering in space over the next decade or so?
Sure. So it's going to be interesting because there's a lot of filings that people have made to put up more satellites in future years. There is not necessarily that many satellites being launched. However, we have seen an exponential increase in the number of satellites launched in recent years, and that's not going to slow down. So it's a mix of how do we, from like a digital services perspective, we've intentionally structured TraCSS to be able to scale with the number of objects that are going to be growing in space. That's a data problem that we've anticipated and have planned for in how we've built the system. But then there's this whole other element of how do you communicate about all these different objects that are going up in space? How do you communicate different best practices around talking when you see a collision, like encouraging satellite operators to talk to each other, avoid collisions, working internationally to really promote best practices around data sharing and coordination, and then seeing how the regulatory space works out as well in terms of what can you or can't you require satellite operators to do.
And that
doesn't. Oh, go ahead.
I say that's going to be a big question because the Congress has a really hard time, I think, keeping up with this kind of technology.
It's already a big question because there's not just considering what do we do in the U.S., but then also internationally as well. We're not the only country up in space operating satellites.
Sure.
So yeah, it's a big thing to wrestle with. Right now, we're taking the approach of making the information available and encouraging people to share and coordinate. But what's called space traffic management, actually telling people what to do, that's a future step that we're going to have to grapple with as a community.
Just a couple of things more. What impact, in kind of your opinion, I know you're probably not in the opinion business, but just kind of talk generally about the impact TraCSS can have on the commercial space industry and its growth.
Well, quite honestly, I think we'll be integral to making sure that the commercial industry can operate both safely and sustainably in space. It's not in a company's business interest to have a collision in space because A, you lose your satellite. B, there's a good chance you just added more debris, which just made it more dangerous to operate, not just for you if you had other satellites up there, or if you want to launch more in the future, but for everyone writ large. The space debris does not just stay in one space, it goes everywhere. So we, from a safety side, I think we're integral. We will be integral, right? Just like right now, the data DoD, Department of Defense provides and the role that we're going to be taking on is going to be integral to safety, but then also from the sustainability perspective, which is making sure that the aspect of making sure that people could continue to take advantage and leverage all the benefits of the space environment.
You know, we've talked generally about satellites and space debris, but people are going to wonder as well, what about the manned space programs? There are going to be more and more manned space flights. How would TraCSS integrate with some of those manned space programs, and what do you think will be the impact there?
So for human spaceflight, not the first time I've been asked this question. So in the near term, at least like things with the International Space Station, they actually have their own program. They have their own person sitting right now at the Department of Defense, helping do their potential collision assessment and whatnot. We'll certainly have the space station. It will be a space object within our repository, but sure. NASA is going to have the lead on NASA objects. But there are a lot more human spaceflight missions happening that are not necessarily tied to a government program or whatnot. So I think it's an area that we're aware of, that we're going to have to learn how to play more of a role in, particularly in terms of there's kind of a larger margin given right now to human spaceflight. So we have to understand what safety thresholds do we want to apply to commercial human spaceflight, what makes sense, what's needed for kind of the safety level versus like the business management level or whatnot. But certainly at the end of the day, I mean, our chief engineer, Sandy Magnus, with the program, she is a former astronaut and actually was on the International Space Station when one of the first red conjunction or potential collision alerts were ever issued. So she has firsthand experience, quite honestly, about how much of a risk this increase in space debris can play to human lives as well. So it's important not just in terms of providing those safety notifications to the commercial human spaceflight missions themselves, but also making sure that we're trying to decrease that background debris writ large. Helps make it safer, not just for the satellites, but for all different types of astronauts that are out there as well.
Christine, we're just about out of time. So how can private space operators and other stakeholders get involved with TraCSS, and how can they learn more about it? The public at large, for that matter.
So we've been working really hard to really expand our informational website. I mentioned earlier, about every 2 months or so, we'll do these kind of public listening sessions around a particular topic on our website, which if you look up Office of Space Commerce and TraCSS, which is TraCSS, you'll see different resources, whether it's along the lines of past videos that we've put out going over the program, different slide decks and resources. We're also very active on LinkedIn and Twitter. And we hope to later this year, or by fall 2025, have our public official TraCSS.gov website up and running. where the public will be able to access information about where all these satellites are, see different visualizations, and really be able to learn for themselves and take advantage of the information that we're providing. So right now we're at the info stage, but this time next year, tracks.gov should be live for everyone.
Well, maybe we can have an opportunity to talk again at that point. I'd enjoy that.
That sounds great. We would look forward to it.
Christine Joseph is Policy Advisor at the Office of Space Commerce, currently supporting the TRACS program. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at XTerraJSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose known by few.